All right, guys, we're going to take a look at 3.5 today. 3.5 is all about operations with matrices. Big deal. I know I had mentioned this last week, but the goal of the second half of chapter 3 is to kind of make that process of solving systems much more efficient. Okay. So as we look at matrices, the first few lessons are going to be kind of delving into what are they and how to perform operations with them. If any of you have used Excel before, or your parents have used Excel, that's all spreadsheet based. That's all matrix based when performing operations. So we're just going to take a look at a few things. Today is mainly going to be setting up matrices, adding and subtracting. Tomorrow we're going to look into multiplying matrices. All right. So first things first, matrices are just a way to organize data. All right. It's clear, it's concise. It removes all the labels from the information. All right. So it's just a set of numbers. All right. And they're arranged in rows and columns. Keep in mind, this is kind of the biggest idea is your dimensions. I'm going to write that down right now, is always going to be rows by columns. Okay. And for whatever reason, people don't kind of mix up the two, but rows go across your page and columns go up and down the page. All right. So Caitlin wants to attend one of 3 Iowa universities. She gathered information below. You have tuition, room and board, and enrollment for each of the 3 schools. And it says organize the information as a matrix. So keep in mind as we organize it, not super particular as far as which way we arrange it. So I'm just going to kind of use the information in the order it's given. And I'm just setting up my matrix with the information below. Notice I do not have labels. It is strictly the organization numbers. And then I'm going to put brackets around my information. So in this case, if we're keeping track, I just set this up as a 3 by 3 matrix. I have 3 rows and I have 3 columns. Okay. It says find the average of each column and interpret the result. Well, in this situation, I guess I can do this quick. So if we add these 3 up and find the average of our column, all right, add them up, divide by 3, we're going to wind up with 5,935. And it says interpret the result. Well, since the column, or the first column, is all tuition, this one would be average tuition. All right. If I average the second column and I get 6,496 or 6,496, what is the average of the second column? Well, that's the average R&D, or room and board. And then the third column, if we find the average, we get 23,059. And then this, if we interpret, would be the average enrollment, not in the entire state of Iowa, but the average enrollment across those 3 schools. Okay, it says, would adding the data in rows be meaningful? Well, as we said, rows go across. So if I added the tuition and room and board, that would make sense. But then if I added 26,160 people to the amount of money, well, that doesn't really make sense. Okay, so going across the rows, since we have different labels, it doesn't make sense to add those together or put those together in any meaningful way, because dollars and people don't go together. All right. Would adding the data in the third column be meaningful? Well, if you look at the third column, again, that's enrollment. All of the labels of that third column would be people. So, I mean, it's probably not meaningful to you, but if we were to add those 3 entries together, yes, we would have total enrollment of 3 schools. So it would be meaningful. It wouldn't be, just a bunch of random information, but it would be the total enrollment of 3 schools. So yes, it would be meaningful. All right. So that's kind of what matrices are. As we look at adding and subtracting, you can look at the chart. Otherwise, you could probably just let your intuition guide you through this. So if you want to, pause for a second and look at the chart, you're welcome to. Otherwise, we're going to go right ahead and just kind of dive into things. I'm going to see if your intuition kind of picks up what to do. So we have a matrix A. Capital letters, by the way, are always used for matrices. So we have matrix A, and we are adding matrix B. Please note, both of them are 2 rows, 2 columns. So both of them are 2 by 2 matrices. What are you thinking you would do? All right. If you're looking at this problem, you might say, oh, you know what? They're the same size. Like, I would probably want to put 16 and negative 4 together. Well, that's exactly how you put matrices together. All right. You put corresponding entries. So 2 and negative 1 is 1. Negative 9 and negative 3 is negative 12. And then 8 and negative 7 is 1. So when we're adding and subtracting matrices, you always want to put those corresponding entries together. All right. Looking at the next one, we have C plus A. All right. C plus A. So we have 8 over 6. And we are adding to that 16 to negative 9 and 8. All right. If you notice, this has 2 rows, 1 column. And this is 2 rows, 2 columns. If you notice, what does 8 correspond to? This one's not going to work. Okay. In order to add and subtract matrices, they need to have the exact same dimensions. So in this case, it does not work. Putting C and A together is not possible. All right. And then the last one here, we have matrix B, and we are going to subtract matrix A. Only thing to keep in mind with subtraction is as we subtract, we need to subtract each entry. All right, so negative 4 minus 16 is negative 20. Negative 1 minus 2 is negative 3. Negative 3 minus a negative 9 is actually negative 3 plus 9, which is 6. Negative 7 minus 8 is negative 15. All right. So adding and subtracting matrices, super easy. All right. Just look for those corresponding entries. The next operation we're going to look at is scalar multiplication, and this is pretty straightforward as well. You can kind of think of this almost as the distributive property. So if I'm looking for 4 of this matrix, what would intuition kind of tell you? Oh, there's a 4 out front. We have those brackets. Oh, you just multiply everything by 4. So we have negative 48, 32, 24, whoops, negative 64. 4 times 4 is 16, and 4 times 19 is 76. And that's your answer with scalar multiplication. Okay, so the 3 operations we're looking at today, adding and subtracting. Make sure your dimensions of the matrix are the same. If they aren't, you can't do it. And then scalar multiplication is just like your distributive property. You're going to want to take whatever number's out front and multiply it by each entry in your matrix. Okay. Just wanted to show you this chart here. There are some properties of addition that hold true with matrices. There are other properties that don't hold true. You don't necessarily need to know these by heart, because I might just ask you to, do K times A plus B or something like that, or A plus B, or show this is the same as this if you did the operation separately. But again, you don't need to know those by heart. I might ask you to perform that operation. Okay. So, and that's kind of what example 3 is all about. So we have negative A, which is 9, 12, 2, negative 6. And we're going to subtract 2B. So we're kind of putting a bunch of things and operations together. And then we need to figure out what the final matrix is? Well, just like with arithmetic, you guys can do it in a number of ways. I'm going to choose to do the scalar multiplication first. So I have 9, negative 12, negative 2, positive 6. And then I'm actually going to switch this to addition and scalar multiply by a negative 2. All right, so I'm going to have 8. Negative 2 times negative 8 is positive 16. We have a negative 4 and a positive 6. Okay, so after I scalar multiplied by negative 2, we wind up with this result. And then we just add them together. So we have 17, 4, negative 6, and 12. All right. So kind of looking at those numbers, pretty straightforward as far as things go. Again, we're looking at adding, subtracting, and scalar multiplication today. If you have any questions, feel free to let me know. Use the discussion board, use those Google Meets, use those live feeds. And that's that. So best of luck. Hopefully today goes pretty well. That is all.